Hello everyone. Good morning. Welcome to the session today. Hope you all can hear me. Can you guys confirm once?
Yeah.
Okay, that's great. Thanks for confirming. So let us start the session, guys. If you guys remember, in our yesterday's session, yesterday was our first demo, if you guys remember. So in yesterday's topic, yesterday's demo, in yesterday's demo, whatever we have discussed, let me gonna list out. And what we are going to discuss today, I'm going to tell you. In yesterday's demo, first I have told you about what is data engineering. Okay. And after that, I have told you about what is Google Cloud Platform. In here also we have seen what is data engineering, what is the role of a data engineer, what are the tools that is used for the data engineering also we have covered. And after that I have told you about what is Google Cloud Platform and what are the benefits of using the Google Cloud Platform, why we need to use the Google Cloud Platform, what is the growth rate for the Google Cloud Platform, what are the roles it offers, all of those details, what are the certifications that we can do for the Google Cloud Data Engineer, all of those details we have seen. And after that, I have told you about detailed course curriculum. So those who have missed the yesterday's session, I have also told you about course details. So these are all details that we have covered yesterday, guys. Those who have missed the yesterday's session, what you have to do is that connect with the admin, try to get the yesterday's demo and watch it and try to complete it, guys. So that you try to understand what is the data engineering and the basics of what is Google Cloud Platform and course curriculum, the entire topics that we are going to discuss for our uh, batch for the 2 months of session we have mentioned yesterday itself. The course details such as how to access the course material and how to access the recordings, all of those details also I have told you yesterday. Okay, in today's session I am going to talk about I'm going to talk about cloud overview. This is our very first topic, guys. I'm telling you, in this session we are going to talk about why we need cloud, why we need the cloud platforms, right? So maybe now we are working on the cloud platforms, but if you go like 10 years before, 15 years before, we do not have any cloud platforms. How people were working with the traditional systems, we are going to understand how people were working in the traditional system are nothing but an on-premises working model, and we are going to see the difference between the on-premises working model versus cloud working model. On-premises or traditional working model are both are same. Sometimes I may be calling it as traditional, sometimes I may be calling it as on-premises. Both are same, guys. There is no difference. Okay, so we are going to understand how, what is the, why we need the cloud platforms, and what is the difference between the traditional working model as well as cloud working model. Then we will try to understand the GCP interfaces. If time permits, we will try to see what are the GCP interfaces are there. Okay, so this is how we are going to start today, guys. So in today's demo we are going to see all of these things. Hope you guys hope you guys can hear me clearly. If you guys are
Yes.
facing any issues with the audio or video, please let me know. Okay, yeah. So let me gonna start with cloud overview, guys, which is very important. You can also see here. So cloud overview is our first topic, and we are going to discuss about why we need cloud platform, what is the difference between the on-premises working model as well as cloud working model. And after that, all of these things comes into the picture. Before that, if anyone have any questions, you please raise your hand, guys. Okay, yeah. Before me starting the session, if anyone have any questions, you can please raise your hand. Okay, no problem. We will see if you have any questions also at the end. We will see it, guys. Okay, so now let us try to understand why we need cloud platforms. Why all the companies are moving towards the cloud. What is the challenges that they were facing in the traditional systems? How the cloud is fixing those problems? All of those details we are going to understand it one by one. To understand it, let us take a simple example. Assume that there is a company and that company wanted to create a new application for their users. Okay, so for some time try to be think like a manager or try to be think like a some customer so that you will understand this topic even more better. Don't think like a student at this point of time. Try to think like a person who is having a little bit more knowledge on the data side as well as infrastructure side as well as something, so that you can even get more knowledge on from this particular topic, only from this particular topic, because what we are trying to understand is about the entire project flow, not only just one simple project. It is about the entire project flow, entire application flow. Let us try to understand. Assume that there is a company. Okay, there is a some company. That company wanted to roll out a new application. They wanted to create a new application for their users. So there will be a user, something like assume that the Flipkart company is there. They wanted to create some Flipkart application for the users like us, right? So that, 1 minute, sorry. So that the people can start utilizing this Flipkart application for the e-commerce transactional purpose. Okay, so assume that there is a company, they wanted to roll out a new application for the users. So if they wanted to create a new application, what they have to do, all of those details, let us try to understand. So first thing is that the business people will be there. What they try to do is that they're gonna gather the requirements of the application. Okay, so what they do, the business comes up with a requirement for the application. Okay, so the business, there will be a business people will be there. What they try to do is that they're gonna be connecting with the users and they get the requirement for the application. And then there will be a business analyst will be there. He will gather all the needs from the business and he analyzes it and converts that into a set of high level technical requirements, and then he passes that information to the solution architect. What the business analyst will do, whatever the requirements that he gathered from the business, and he will try to analyze it, and he converts that into a technical information, and he passes that technical information to the solution architect. Now the solution architect will come into the picture and he will design the architecture to be followed for the deployment of the application. Okay, what the solution architect will do, he create an architecture diagram to be followed for the application deployment from the scratch to the end, whatever the things that he needs. All of those things, he put it into an architecture diagram. Okay, he put it into an architecture diagram so that the people multiple teams has to follow this one so that finally the application will be created. So this architecture diagram typically include two things. One is infrastructure, one more is code. Because if you wanted to create a new application, you need two things, guys. One is the infrastructure. That means, what do you mean by infrastructure, Sad? It could be a number of servers. It could be a front-end database or back-end database. It could be a storage. It could be a RAM. CPU, all of those details that are required for the application deployment. He will put it into the architecture diagram. And for the application, if you wanted to create it, you need to deploy the code. So what programming language they have to use and how they have to use, what is the procedure of this code. So that is also, he will mention that all of those details about the code also. So if you wanted to create one application, you need two things. One is infrastructure as well as the code. So in his architecture diagram, he will mention both. Now, can you guys tell me who will create the code? Can you guys tell me who will create the code?
Developers.
Developers. Nothing but there will be an application team will be there. They will create this code. Maybe if they have mentioned the Java application or a Python application according to the programming language, they are going to create the code. The application team will create the code. Can you guys tell me who has to take care of the infrastructure?
DevOps team.
There will be a DevOps team or there will be an infrastructure team. They have to take care of it. But when we are working in the traditional working model, infrastructure team or DevOps team, whatever it is, right? Okay. So if they are working in a on-premises working model, can you guys tell me if the, what do you mean by infrastructure? First, let me gonna mention the number of servers,
Yeah.
right? Or it could be a storage, or it could be a some other things like networking features, or it could be a
Memory.
memory, RAM, CPU, all of those details. So who has to take care of this thing? Who will
Mhm.
purchase? If the company is working on an on-premises working model, who has to create all of these things, guys? Who will have to take care of all of these things? The company has to take care of it, because if the company has all of these things, then only the infrastructure team will try to utilize it and they create the infrastructure required for the application. If this is not available in the company, because all the infrastructure elements has to be available in the company's data center only. If those elements are not there in the company's data center, okay, so whatever the required things for the application deployment, the infrastructure has to be available in the data center. If that is not available in the data center, what the solution architect will do is that he will create a request to the procurement team for the purchase of the new hardware requirement, for the purchase of the hardware requirement, right? So if the entire infrastructure is already available in the data center, then there is no problem. The application team can directly deploy it. But most of the times, the infrastructure is not available in the data center, because the required infrastructure required for the existing applications, it is already there in the data center. But we are trying to create a new application. For the new application, the entire infrastructure may not be available in the data center. If there is an additional hardware is needed, they have to order it via procurement team. They have to order it via procurement team. Now this team will put in a new request to the vendors team. Now the procurement team will put a request to the vendors team. Now the vendors team, what they will do is that they will go to the hardware shop, they will purchase it, and they will deliver it to the data center. They will deliver it to where, sir? They will deliver it to the data center. So this is all the things has to be taken care. Okay, so when you are working on an on-premises working model, if the additional hardware required for your new application, okay, if the additional hardware is not required, then there is no problem. But most of the times, whenever they wanted to create a new application, they need some kind of additional hardware. Some elements might be already available, but few of the items may not be available, right? So if the additional hardware is needed, the solution architect team will have to order it via procurement team. Now the procurement team will put in a request to the vendors team. Now the vendors team will try to go to the hardware shop, they purchase the hardware and they deliver it to the data center. They deliver it to the data center. So this is how now the hardware is available. If the hardware, new hardware is available, can we directly utilize it for the application deployment?
No, we need to
Can we?
set up operating
Right?
system with
So correct.
actually.
So we cannot directly utilize this hardware because we need to do a lot of configurations. Okay, for that purpose there will be an infrastructure team come into the picture. First people is that the field engineers. Field engineers will take this hardware and they try to set it up in the rack and stack equipment. There will be a field engineers, they will set it up the rack and stack for this particular equipment. What is mean by rack and stack means, so this is what is mean by rack and stack. So whatever the hardware that they have mentioned, right, so this is what we call as the rack and stacks, guys. So the entire additional hardware whatever they have got it from the vendors team, they will put it like this.
Yeah.
Okay, and after that, the system admins comes into the picture, the system admins. So what the systems admin will do is that they will do the initial configuration of the system. Okay, they will do the initial configuration of the system, and then the network admins will come into the picture, and what they will try to do is that they do the network so network configurations, so that all of these systems will be available over the network. Okay, so system admins will do the initial configuration of the system, and the network admins will try to do the network configuration so that all of these systems are available over the network. Now, the storage admins will try to assign the storage to the servers, and the backup admins will try to configure the backups. Okay, so these many people has to, these many different team have to work behind the scene, so that the entire hardware is the entire hardware they have purchased is according to the application deployment infrastructure. The whatever the infrastructure that they need as per the application deployment, now they have set it up. All of these teams have set it up, right? So once the all the systems are set up as per the standards, now it will be handed over to the application team. Now the application team, whatever the code that they have developed, right, they are going to deploy that code on top of this infrastructure, on top of this infrastructure. So this is how your application is ready and smoothly running in your data center, application data. So this data center, who is managing, sir? When you are working in a traditional working model, your company has to set up this data center. Your company has to manage this data center. Your company has to maintain this data center for 24 by 7 electricity, 24 by 7 water supply, cooling supply. Expert people has to be available for the maintenance and monitoring. All of those detail has to be taken care by the company itself. Okay, so this is where once the entire infrastructure is set up as per the standards, the application team will deploy the code on top of this one, so that your application is readily available to the end users. So this is what is a traditional working model, guys. In a traditional working model, this is how people were working if they wanted to create a new application. Okay, if they wanted to roll out a new application, the business comes up with a requirement for the application. The business analyst will gather the information and converts that into a technical information and passes that into the solution architect. Now the solution architect will create an architecture diagram to be followed for the application deployment, which typically includes the infrastructure details as well as code development details. So if the additional hardware is required for the application deployment, the solution architect will create a request to the procurement team. Procurement team will connect with the vendors team. Vendors team will purchase the new hardware and deliver it to the data center. Once the new hardware is received at the data center, the field engineers will come into the picture. The system admins, storage admins, network admins, backup admins, then the application team will try to deploy the code on top of the infrastructure. So this is what is we call it as a traditional working model, guys. This is what we call as a traditional working model. If you follow a traditional working model, for creating a new application, these many teams has to work behind the scene. Then only the new application will be created. Can you guys tell me what is the problem with this particular procedure? Can you guys tell me what is the problem with this particular procedures?
Yeah, I mean, getting a new hardware is always expensive process.
Correct. So someone says time, someone says the hardware. Both are correct. So the turnover time varies from weeks to months, because you look at here. So the solution architect is trying to create a request to the procurement team. The procurement team is connecting to the vendors team. Now the vendors team may take weeks or sometime months, okay, for the entire new hardware to be purchased and delivered to the data center, right? So the vendors team taking a lot of time, the procurement team take a time. So this is the reason the turnover time varies from the weeks to the months for the entire application to be ready. And one more thing is that the if I wanted to scale up, for example, my application was running very good. That means plenty of the people are using it. That means I have to scale up. That means scale up means I have to increase the resources so that many people can start utilizing it. Is the scaling up and down as per the requirement is achieved quickly or not? Can you guys tell me?
Even that is also difficult.
It's a
We
very
have,
difficult, right? It is because if you wanted to scale up, that means the number of infrastructure or resources or hardware, you have to increase it. If you wanted to increase it, again, someone has to put in a request, they have to purchase it, and they have to deliver it. Again, it takes a lot of time. So that is the reason the turnover time varies from weeks to months for the entire application to be ready, as well as scaling up and down for the requirement. And one more thing, that is what we call as a slow deployment model. Okay, because it is taking a lot of time, so I'm going to call it as a slow deployment model. I hope you are okay with this one.
yeah,
So this is one of the problem. Now one more problem I am saying, it is expensive, because the overall cost to maintain this working model and deploy the application is very high. Look at here, many teams are working on. I have to recruit many people for this activity. And data center, the data center maintenance itself, it is a very huge cost. So that's the reason the overall cost to maintain or deploy this working model is generally high. So that's the reason I am calling it as a expensive working model. Hope that point is also clear.
yeah,
And one more thing I would say is that you are working on a traditional working model. Most of the activities are done using these multiple people. So some of the aspects can be automated, but most of the aspects cannot be automated here. Such
yeah,
as, so whatever the field engineer is doing, the rack and stack cannot be automated. The whatever the purchase that they are doing, this cannot be automated. So this cannot be automated, this, so most of the things cannot be automated, but some of them can be automated. So that's the reason I am calling it as a limited automation. Hope you guys are okay with this limited automation thing as well, right?
yeah, yeah,
Some aspects can be automated, but some aspects cannot be automated. So that's the reason I'm calling it as a limited automation. And one more thing, I'm going to call it as human error. Why? Because so many different people working on a different teams, working on a different task. The chances of human error is generally high. Okay, the chances of human error is very high here, which may results into the inconsistency in the environment, which may results into the inconsistency in the environment, right? So when many teams working on a different task, there are chances to the human error, which leads to the inconsistency in the environment, right? So that is also clear. And one more point is that underutilization of the compute resources. Okay, so you are purchasing a lot of infrastructure, but you may not be using it 100%. So that leads to the underutilization of the compute resources. That is a unnecessary cost that you have put, a lot of effort that you have spent, and lot of money we have spent on it. So that is leads to the wasted resources. Okay, so this point is also clear. So
Yeah.
this is the reason these are the challenges that the people were facing when they are working on a traditional working model. When they are working on a traditional working model, so they are facing that the first problem is slow deployment model. The traditional working model is a slow deployment model because the time taken for the new application deployment is taking a lot of time. And similarly, if I wanted to scale it up and down also, it is taking a lot of time. And one more thing is that the cost to deploy and maintain the working model is very high. And some aspects can be automated, but most of the aspects cannot be automated. That is leads to the limited automation. Because of so many teams working behind the scene, the chances of human error is very high, which is leading to the inconsistency in the environment. The underutilization of the compute resources is also there, which leads to the wasted resources. So these are the challenges that the people were facing, the companies were facing, guys. So that's the reason from the last few past decades, I would say, the companies are looking for an alternative solution for the traditional working model. And that's where you have cloud came into the picture, guys. So that's where you have the cloud providers came into the picture, right? So what is the cloud provider do? The cloud provider provides you the infrastructure as a service to you, so that you don't need to maintain this all of these people. Okay, you don't need to maintain this all of these people, guys,
Yeah.
because the cloud provider provide the infrastructure. You don't need to maintain this one also. Okay, the cloud provider provides you the resources to you. What you will do is that you will keep a DevOps engineer, and they will create the resources in the cloud directly. So whatever that they have mentioned in the solution architecture diagram, they will create it directly in the cloud provider, in the cloud platforms. And now the creation does not take hardly 1 or 2 hours. But when you are working in the traditional working model for creating the infrastructure, you are taking days or months, and sometimes, sorry, you are taking days or weeks, sometimes in months also you are taking, right? So that is the reason the traditional working model is a slow deployment model. But when you are working in a cloud, if you wanted to create the infrastructure, it is hardly in few hours only you can able to do it. In few hours itself you can able to create the infrastructure, guys. So that is the reason most of the companies now started utilizing the cloud. It's because that when you are start deploying the resources that much faster, the deployment model will be very faster when you are working in the cloud platforms. When you are working in the cloud platforms, the deployment will be very faster. Can I remove this point
Yeah.
for the cloud computing model? Because so if I wanted to deploy it, the application team is fastly creating the code, and the DevOps team is creating the infrastructure in few hours only. So the deployment is happening in within few hours or few days itself. So that deployment will be very faster compared to the traditional working model in the cloud. And one more thing also, now I don't need to recruit all of these people first thing. I don't need to do the salary to them. And one more thing, I don't need to maintain the data center itself. So that's the reason the cloud computing cost, the cloud working model cost will be comparatively less to the traditional working model. So that is the reason I am removing the expensive also here, because compared to the traditional working model, the cloud is cheap. So that is the reason most of the companies are looking towards the cloud. And one more thing is also, we already know that the cloud platforms comes up with the advanced features, such as it most of the cloud services are works via APIs. If something is working via APIs, nothing but application programming interfaces, the chances of automation is 100%. You can achieve the automation 100% if you are working with the APIs. Each and every service in the cloud works via API only. You can do the many aspects with the automation itself. Okay, most of the aspects can be achieved automation quickly. So that's the reason we call it as a fully automated. Okay, it is not limited automation. And one more thing is that now that you do not have this many teams, now that you do not have this many teams, now the chances of human error will be very low because there are not many teams working on this thing, and it does not lead to the inconsistency environment. So that is also not there. Now, one more thing is that in the cloud, the best thing is that so according to your requirement, you can increase the resources, you can decrease the resources. You don't need to buy a lot, you don't need to buy less. You can buy as much as required for you today, and tomorrow, if you wanted to scale up and down as per your demand, you can do that. So that leads to the proper utilization of the compute resources, which does not have a problem of wasted resources, right? So you can properly utilize the computer resources. If you think that you are underutilizing it, you can remove them. That means you can scale down. If you think that you need more resources, you can scale up. So that is what is the benefits of the cloud. Okay, so these are the problems or challenges that they were facing in the traditional working model is fixed by the cloud platform. So that is the reason many companies, startup companies, MNC companies, product based companies, mid-level based companies, all companies are started utilizing the cloud for their different project fulfilling purpose. Okay, because if a startup company, if they wanted to start a new business, they need to create the data center. That's a nightmare. Now they can utilize the resources of the cloud for how many years. If they wanted to utilize it, they can start utilizing it. Later point of time, if they don't need it, they can remove the resources. And whenever they are using the resources, they have to pay the cost. That's it. In a simple words, if you wanted to understand the cloud, as I told you yesterday also, okay, so you can do two things. For example, you wanted to eat food, assume that. In a simple words, if I wanted to, you wanted to eat food, guys. To eat, if you wanted to eat food, what you have to do, sir? How many ways we have? One is someone has to prepare it, right? So if you wanted to eat food, either you have to prepare it or someone has to prepare it. Assume that you are preparing the food. Tell me, guys, what are the challenges of preparing the food at home? You need to have a stove. You need to buy all the raw material, such as if you are eating chapatis or if you are eating bread or rice or whatever it is, you have to buy it. You have to buy the veggies. You have to buy the all the things, and you should know the how to cook also. And after that, once all of these things is done, you after you cooking it, then you can have the food, then you can go for the food. So this is how, if you wanted to eat the food, you need to go to the grocery shop and you need to buy all of these things, which may take 3 to 4 hours. Buying all of these things, it will even take more than that also, but let me take 3 to 4 hours for you to have food. But instead, what we can do, sir? If I don't wanted to prepare the food, what I can do? Correct, we can order it from the restaurant. So it hardly takes 1 hour, or you can go to the restaurant and order the food. It hardly takes 10 to 15 minutes for the food to be ready, and you can have it, right? So this is how it is. So this is what is called as a on-premises working model. In on-premises working model, you and your company has to take care of all of these things. Okay, maintaining the infrastructure, creating the infrastructure, maintaining the data center, purchasing the hardware, delivering the hardware, everything has to be taken care by the on-premises working model. But when you go for the cloud, this restaurant is nothing but a cloud. So when you go for the cloud, you don't need to wait for a lot of time. You just order it and hardly 10 minutes they will serve it to you. You can have it. Okay, so the on-premises working model, you are putting a lot of effort to create the infrastructure, lot of money you are spending into it, and lot of time you are spending it. So these are the problems of the main problems of the on-premises working model. That is fixed by the cloud computing. So you don't need to put a lot of effort, you don't need to spend a lot of time, you don't need to spend a lot of money also. So that is how cloud computing model giving you the benefit. Okay, so this is what we call as a, this is the reason guys we need the cloud platforms. So this is the main reason that you need the cloud platforms. Okay, so back to the slide. Okay, so this is what it is. If you wanted to see the difference of the traditional working model as well as cloud working model, now you have seen it, but in a simple terms I wanted to give you the definition. Sir, in a on-premises working model, an organization or a company managing its own infrastructure to run their code or applications. If an organization managing its own infrastructure, then that working model is called as a traditional working model or on-premises working model. Sir, what is meant by infrastructure, sir? Infrastructure can be a servers, can be a hardware, software, networking, storage, all of those things. Hardware rise such as RAM, CPU, all of those things comes into the picture. So this is what I call as a infrastructure. Okay, in a traditional working model, the company has to maintain the infrastructure for running their application or a code. But in the cloud computing model, the another company, another cloud provider will deliver you the infrastructure as a service to the company so that the company get benefited by just focusing on the innovation instead of infrastructure maintenance. Right? So this is what we call as a cloud computing model. In a cloud computing model, another cloud provider provide you the resources to you for your application deployment so that you can focus on the innovation instead of the application infrastructure creation. Right? So that is what is we call it as a cloud computing model. That is what we call it as a cloud computing model, guys. Okay, hope that is also clear. Does anyone have any questions until this one? Because I have just completed these two things. If you guys have any questions, you can ask me. Please raise your hand, guys. Cloud overview, why we need the cloud platform, the difference between the traditional versus cloud platforms we have just discussed. And I will give you some overview on the GCP interfaces also in next 2 minutes. Before that, if anyone have any questions on these things, you can ask me. Any
No questions.
questions?
No questions.
Okay, that is great. Thanks for confirming. Okay, so let me gonna tell you guys. Okay, hope that is clear. I'm going to talk about the GCP interfaces. I'm going to give you just overview on GCP interfaces. Then we will see in our upcoming sessions how we are going to, because whenever we are working with them, you will get even more comfortable. So let me going to talk about the GCP interfaces. We have three interfaces are there, guys, in the GCP to work with the multiple services in the GCP. One is console, one more is cloud shell, one more is cloud SDK. Okay, so let me going to talk about what is console, what is cloud shell, what is SDK.
Console is
Yeah,
browser.
let me gonna tell you. Okay, first concept is first console. Okay, even before that, to set the context. Now tell me, guys, what do we want it to do with the Google Cloud Platform? Can you guys tell me? What do we want it to do in the Google Cloud Platform?
See, it's like an environment where we can deploy applications. We can create
Correct.
an environment.
So In
Yes,
Google
yes.
Cloud Platform, you have a plenty of GCP services. It is there. That means it is providing you the plenty of services to you, right?
Uh-huh.
Services such as, I would say some of the services I'm mentioning: GCS, Cloud SQL, BigQuery, Dataproc, Dataflow, Airflow. Okay, and just giving the short forms. Okay, don't worry about that. Airflow, Cloud Functions. So plenty of these things. Data Fusion is there. So Google Cloud Platform is providing you the plenty of services to you. So we as a data engineer, what do we want it to do? Can anyone tell me? What do we want it to do in the data engineering with the GCP services? What are the things that we want it to do as a data engineer?
So we want to do the ETL transformations by using services
So
like
let
such
us
as
start from the very basic. So we
ingest,
wanted to ingest the data from the multiple data sources.
right?
We wanted to store the data. We
Mm-hmm.
wanted to process the data,
Mm-hmm.
analyze the data, and visualize the data, transform the data,
Right.
visualize the data, and we wanted to do the data governance. So many other things, monitoring, many other things we wanted to do.
Mm-hmm.
So you as a data engineer, we as a data engineer, we wanted to perform all of these activities in the Google Cloud Platform. So if you wanted to perform all of these activities in the Google Cloud Platform, sir, can you tell me how can I interact with these services? How can I interact with these services? Those interaction methods I'm talking about is console. The very first method is console. The second method is cloud shell. The third method is cloud SDK. Okay, so total we have three methods are there. One is console, the second one is cloud shell, the third one is cloud SDK. So these are the three interacting methods are there to do all of these activities in Google Cloud Platform. Okay, so this is what is GCP interface. These things I'm calling as a GCP interfaces, guys. These things I'm calling as a interfaces. Interfaces to interact with the multiple services in the Google Cloud Platform, right? So let us try to understand what is console and what is Cloud Shell in few minutes. Then we will wind up the session for today. Okay, is it
Yes.
clear? Yeah. Now let me gonna tell you about console. Okay, what is console? Sir, console is a web-based,
UA interface.
yes, graphical user interface. Okay, sir, what is a console? So console is a web-based graphical user interface to interact with the GCP services. So how do we interact with the GCP services, sir? Can you guys tell me how do we interact with the GCP services? So in a console, if you wanted to interact with the GCP services, you are going to interact it visually. Okay, you are going to interact with the GCP services visually. So this is what is console, sir. A console is a web-based graphical user interface to interact with the GCP services visually. So how do we do that, sir? Let me gonna open the Google Cloud Platform for you. In our next session, I am going to tell you guys how to create a free tier account in the GCP. Stay tuned. And I am now telling you how this console works. Sir, what if you wanted to enter into the console homepage of Google Cloud Platform, you need to type console.cloud.google.com. Just click on enter. So this is where you are inside. This is the page. So this is what is console, sir. This is a graphical interface. So if you wanted to work with BigQuery, what you are doing it visually, you are interacting with that particular service visually, right? So visually with the command, with visually with the help of this particular interface, you are going to interact with the services. So if you wanted to create a bucket, visually you are doing it. So that is what I'm calling as a console is a web-based graphical user interface to interact with the services visually. Okay, so that is what is console. That's it. And you have a next method that is cloud shell, as I told you, right? So what is a cloud shell? The cloud shell by name itself we can say is that first it is a web-based command line interface, CLI. I would say that it is CLI. So cloud shell is a command line interface, guys. So can you guys tell me how do we interact with the services here? Can you guys tell me how do we interact with the services, guys, here?
By executing Google commands.
So we need to run the commands. Perfect. Correct. So if you wanted to interact with the GCP services with the help of the cloud shell, you need to run the commands. Okay, you need to interact with the services via commands only, because cloud shell is a web-based command line interface to interact with the GCP services via commands.
Mhm.
Okay, via commands. Where it is, sir? It is a web-based. Can you show me? So if you ask me, so if you go here, you have here activate cloud shell button. If you guys can see here, activate cloud shell button. Click on it so that the cloud shell environment gets opened at the bottom. Cloud shell environment gets opened at the bottom. Okay, so this is how you can also open this entire window. This entire window you can open at the next tab itself so that it opens. Okay, so you can close it up here. You have the entire session here. So this is what I'm calling as a cloud shell, guys, which is called as command line interface. If you wanted to interact with, for example, so I wanted to list out all the buckets. See here, I am able to list out all the buckets using the console. So that I click on the buckets cloud storage so that I am able to list out all the buckets. Similarly, if you wanted to do it, you need to run some commands. GSUTLS. The same buckets, number of buckets will be listed out here. Look at here. See, so the same number of buckets. Here we have 4. Here also we have 4. So if something can be achieved using the console, can also be achieved using the cloud shell. So if you are trying to interact with a bucket from the cloud shell, you can also do the same thing from the cloud shell, also from the cloud console also. So this is what I call it as a cloud shell, guys. One more thing about the cloud shell. So this is what I call as a, so there are two things about the cloud shell, guys. So this is cloud shell. You have a terminal. When you open the terminal opens. So you have an editor also. You can also open the editor. So two things. Editor is like your code editor. Okay, so if you go to some Visual Studio Code, if you are editing the code, right, you can also edit the code here. So this is how we are seeing it as a code editor, guys. You can run some script and you can create some script. So that is the reason cloud shell has two phases. One is terminal. Terminal is to purely run the commands. Editor is like your code editor. It comes with the version control capabilities as well. So these are the two things are there. One is terminal, one more is editor. So these are the two things are there. Okay, so in the cloud shell you have a terminal, you have an editor. You can see here both. So here also you can see you have the terminal you have the editor at the top, terminal at the bottom. Both the things are here. Okay, so this is how it is.
Yeah.
and and the third method that we have is, if you wanted to interact with the GCP services from the local,
SDK.
we have SDK from the local machine. If I wanted to interact with the GCP services, because SDK is what, sir? It is a local based. When I say local based, according to the operating system, you have to install this SDK on top of your local machine. According to the operating system, you have to install the cloud SDK or cloud CLI on top of your local machine. So again, SDK is what, sir? It is also a CLI, command line interface only, to interact with the GCP services via commands. To interact with the GCP services via commands only. The same thing. Okay, so this is what is SDK, sir. How do we install it? So if you wanted to install it, I have also mentioned in our notes also. But if you wanted to install it, you can go and click on install SDK. So here is the link, guys. You can click on this link so that you can see install the Google Cloud CLI, nothing but a SDK only. So according to the operating system, if it is Linux or Ubuntu, Red Hat, Fedora, CentOS, macOS, Windows, Chromebook, whatever operating system that you have, you should be able to install it on top of your local machine. Once it is installed, for me it is a Windows operating system I have already installed. So this is how you can able to open it. This is how you can able to open. Once you have opened it, you need to connect it to your Google Cloud account, right? So for that purpose, G Cloud auth login. So you need to do the G Cloud auth login. So it will do the login. We need to do the login. Select the account, click on continue. Cloud SDK is accessing your Google Cloud account. You want it to allow? Yes. So that's where it gets logged in. That's where it gets logged in. So this is how you should be able to do the login. Here also you can run the same command gsutil ls, for example, if you wanted to run it. Okay, the project is different, project is selected, so that's the reason the number of buckets will be more, maybe, right? So this is a different project. Okay, so that is how, if you wanted to interact from the cloud SDK from local machine, because it is not cloud, sir. Okay, so it is not on the web. Now this is not on the web. You are doing it on top of your local machine SDK. Whatever you have installed on top of SDK and you can open it from your local machine itself. So that is what we call as the cloud SDK. According to your operating system, you have to download it and install it on top of your local machine, and you can able to interact with the GCP services from locally itself. Okay, so this is what is SDK. So these are the three methods are there, guys, if you wanted to interact with the GCP services. So all the three methods I have given you some idea.
Yeah.
Console web-based graphical user interface, Cloud Shell web-based command line interface, SDK local-based command line interface. If you guys have any questions, you can ask me, guys, now. Please raise your hand if anyone have any questions.
No questions.
Okay. So with this one, we have completed our demo sessions, guys. Let me gonna tell you, if anyone have any questions, you can ask me also. We have completed our demo sessions. From tomorrow onwards, regular sessions get started. Okay, the time is same, 7:30 to 8:30. Okay, so those who wanted to continue to attend the regular sessions, please complete the registrations. Okay, what you
Yeah.
have to do is that please complete the registrations. Okay, do the registrations, guys, enrollment or registration, whatever it is you call. Okay, connect with an admin, complete the payment, get the access to the material, get the access to the notes. Do two three things you have to do, guys. Okay, those who wanted to continue to the regular sessions, because don't ask me later point of time, sir, I do not have an access to the recordings, I do not have an access to the notes. So those who wanted to attend the regular sessions, first thing what they have to do, complete the enrollment for the course. Once you do the enrollment for the course, ask the admin, give me the access to the notes. These notes. You need to get the access to these notes. Once then you have the notes access also, get the access to the recordings also. Get the access to the recordings. Both of the things, try to do the complete the enrollment today itself. Try to get the access to the notes and recordings. Okay, do this activity, guys.
Yeah.
Okay, yeah. Anyone have any questions, please?
No questions.
Okay, if you do not have any questions, we can wind up the session for today, guys. Thank you all.
Thank you. Thank you.
Thank you. Thanks for the session today. Yeah. Thank you, guys. Bye bye.